So, grüezi miteinander and welcome to the presentation about the project Economic Impact of Decarbonization in the Transport Sector. It's a joint project between Infras with Markus Maibach and with the ETH with Professor Lukas Brečker. My name is Noah Wright. I'm a PhD candidate at the Chair of Resource Economics at ETH. And with me today is Martin Peter, the Head of Department of Economics and Environment at Infras. We all know the transport sector is of great importance in today's economies. We eat bananas from Ecuador, we travel to the sea, and we are too late for a meeting if the train has a Stellwerkstörung. And however, we know as well that today's transport sector has a high contribution to the greenhouse gas emissions. In Switzerland, 39% of the greenhouse gas emissions are transport related. Furthermore, the transport sector in Switzerland is not yet on a clear emissions reduction path. And the political discussion about the pathway of the transport sector is still in its infancy. With that in mind, and facing the ambitious Energiestrategie 2050, we see it as crucial to get an answer to the following research question. What combination of measures and instruments for decarbonization of the transport facing new technologies arising on energy and transport markets, to achieve that, we have different objectives. First of all, we want to fill a research gap. We want to analyze the economic impacts, chances, and risk of decarbonization for Switzerland towards a green and sustainable transport economy. To develop different decarbonization scenarios for the transport sector in Switzerland, to assess and to compare those scenarios. Within the study, 3 framework scenarios until 2030 and 2050 will be elaborated. The framework scenarios are the following. We have the technology approach, which deals, for example, with an increase of motor vehicle efficiency towards a carbon-less technology. And the second approach is the efficiency approach, which deals, for example, with a reduction of traffic demand by a more transport-efficient organization of the society and the economy. And we have the modal shift approach, which deals with a modal shift of the transport modes. The goal of the framework scenarios is to show the contribution to climate goals by different approaches and the related economic and social impact. We will construct a comprehensive bottom-up computable general equilibrium model about the transport sector in Switzerland with a focus on energy use. We then combine this model with the strength of the already existing site model to get the so-called site T model. The site model is a general equilibrium model dealing with the world economy with special focus on Switzerland and energy commodities developed by ETH. The site T will give us information about long-term macroeconomic effects, effects in the transport sector, distributional effects, and the energy use. The procedure is as follows. In the first step, the system boundaries and the decarbonization targets until 2030 and 2050 will be defined. Secondly, a business-as-usual scenario called BAUS scenario will be developed. The BAUS scenario will be the reference path for economic modeling, economic modeling and assessment of different decarbonization scenarios of the transport sector. We then elaborate 3 didactical scenarios analyzing the potential contribution of technology measures, efficiency measures, and modal shift measures to the decarbonization of the transport sector. Out of the framework scenario, an optimal scenario shall be calculated by the model with the following characteristics. Climate targets are achieved and maximization of GDP. Then the model results will be embedded and complemented by a criteria-based assessment of all scenarios. This will show strengths and weaknesses of the different scenarios out of a broader view and help to identify trade-offs. And as a last step, we will disseminate the analysis and the results. Our contribution is a comprehensive dynamic CGE model which contains endogenous growth, the ability to analyze transformation in transport sector, and interaction between energy demand of transport sector and transport supply. Additionally, we will detect a feasible path of decarbonization of the transport sector in Switzerland, and due to the combination of theoretical and practical expertise, we are convinced that our results will not just be aloof, but relevant.